Hello, this is Paul from Foresight Tech. In this lecture, I will going to introduce another method to find the value of a solid revolution. Solid of revolution by using cylindrical shells. Remember the last topic we use discs or washers to find the value, but this time we have another new method. And later I will going to show what the difference between these two methods. So here is a summary. So can you see this graph? First we have a region. So this is the function y equals fx, and between x between a and b. See, we have a region, and then this time we will not take the region rotated about the x-axis. So x-axis is here. However, we will take this region rotated about the y-axis. Rotated about the y-axis. Remember, if we do this, if we rotated this region about the x-axis, remember that's the normal way, and we have the topic the last time, right? So how to do integration? We cut along x, and so we can use the discus. However, it's not rotated about the x, it's rotated about the y. How do you think? So you imagine what is the solid looks like. This region rotated about the y. See, with the middle should be empty, right? And it looks like water, and the shape looks like a cylinder. However, it's not exactly a cylinder. But look at the top. Look at the top is very complicated. The surface. Okay, the surface should be very complicated. Okay, it's not a plane. Therefore, it's not a cylinder. So, how to find? Can we just cut along y? The last class we can either use disc or washer. Okay, imagine if we cut it, we have a hole in the middle. So probably you can use the washer's method. If we use the washer, we look at the surface. I look at the surface. Do you think it's easy to resolve the radius? Too complicated to resolve the radius. Okay, I mean the washer's method does not work well. Of course, the discus does not, definitely. So how do you find the volume of the solid? And we imagine in another way. So this time we think about this. The original region we cut first. Okay, we first cut the original region in pieces. I take one as example. The middle one is cut into small rectangle. Everyone remember this to integration. Cut one small rectangle from x to x plus delta x. So we know the width, we know the height. The height is the value of the function at x, which is fx. And then we take this small rectangle, remember, rotated about the y. How do you think what kind of that small solid we will get? That's exactly the cylinder. This time, exactly a cylinder. Why? Because this is a rectangle, and then you see the radius is x, the height is fx. So if you rotate it, what do you get? You get the cylinder, right? This cylinder, of course, in the middle is a hole. There's a big hole in the middle. Okay, I mean this is just the cylinder shell. We simply say is a cylinder is only very thin. Okay, it's very thin. Why? The thickness is delta x, right? The thickness is only delta x. Okay, when we take a limit, delta x goes to infinitely small, and this is not it. This is just we call the cylindrical shell. It's just a shell. You can imagine, just a shell. Okay, so now, so the idea for integration, if you find if you find the value for each shell, all right, each shell you find the value, and then do integration from A to B for all the shells put together. That's the total value, right? That's the value for the solid of revolution. And how to find the shell? Okay, how to find the value of the shell? So you imagine what the shells look like. So rotated, the radius is x. X is what? A radius, right? X is a radius. So this we know is a radius. And so if we know the radius, then we know the circumference, right? 2 pi times the radius. And another, the height, we know this is f(x) is the height, right? How high it is. And the delta x, you know, is the, we say the thickness, how thick. Okay, find the value, we do this. We cut 1, we just open the shell. If we open the shell, you can imagine what is the solid. So this time the shape is goes to what? Goes to cylinder. Their cylinder is a rectangle, right? So the bottom that goes to rectangle. Okay, so we find it like a cube. It's not a cube, rectangle cylinder. So rectangle cylinder, how to find the value? So that's easy. The area of the bottom times the height. What is the area of the bottom? Area of the bottom is rectangle. So 2 pi times x, the circumference. Okay, so you take, if you open and at the bottom, everyone goes to the circumference 2 pi x. What is the width? The width, of course, is the thickness is the delta x. What is the height? The height is the original height. See, you can imagine you open, you will get this solid, and this value is easy to find. 2 pi, the circumference, it is 2 pi x circumference times height and the times delta x, or you say the dx. Okay, it's the same. Can you see? So the circumference times the height times the thickness, what do we get? That the value of the cylindrical shell, each shell. How many shells do we have infinitely? Okay, do integration for what? For x from a to b. See, integration for x from a to b. And this is the formula. This is the formula for our new method about the cylindrical shell. And this is totally different. Keep in mind, this is totally different from the previous method. Okay, and this time is not a cut. What is not a cut along the axis of revolution. For the disk or washes method, we always cut along. Remember, integrate along the axis of revolution, right? But this is not. This is another. And also each small part is a cylindrical shell. It's not a disk, it's not a washer, but a cylindrical shell. And the value of the cylindrical shell, so we do this strategy and then find it here, and then do integration. What I just said is the first, the remark 1. Compare the method of discs. Remember, for the disk or washers method, integration is always along the axis of revolution. But this method, cylindrical shell, is different. Okay, does not along the axis of revolution. That means what? See, the axis of revolution is y. We did not integrate about the y. However, we integrate along what? Along x. Okay. Look at the second. So we have the second. The method of cylindrical shell is very useful. Okay. When usually we do this. Discs or washer is easy, right? The formula looks much easier. However, the discs or washer does not always work for your questions. So, like for example, when the radius in the method of discs or washer, if you need to find what? You need to find the radius, right? If you cannot find the radius, so your method, either discs or washers does not work, right? In that case, try to use which method? Cylindrical shells method. Probably cylindrical shells will solve your problem. Look at it. We put them together, we have 3 methods, right? So either do discs or do the washers, or do this cylindrical shells method. One question, so let's look. Find the volume. Find the volume of the solid. This volume first is by the region is formed by these curves, 1, 2, 3, 4 curves, and then the region and the taker rotated about the y-axis. So we need to find the region first. Well, the region, if I put here, we had these questions before, so it's almost the same. I'll draw like this. Get a little bit not sure. So this is the origin. If I say this is y, this is x. What's this? Y equals x squared. Okay, so x squared equals y. So this is a parabola. Okay, remember this. Still parabola. Parabola. And then we're going to draw the parabola. This time the parabola, when x equals 0, y is 0, right? So go through the origin. And then x goes up, but y goes up. So I simply say, look like this. I'll just roughly get this graph, okay? Okay, I get this. X equals 0. X equals 0 is the y-axis. Y equals 0 is the x-axis. Y equals 6. I put the y equals 6 like this. Okay, I just get this. So this is 6, and so this side is y equals 6, and this side is y equals x squared plus x. And then what is the region? Of course, the region is here. This is the includes the region. And then now we do what? Keep in mind that rotation is about the y-axis. We're going to rotate. This is about the y-axis. We do this rotate. So everyone, so get this region rotated about the y. Now we have the solid of a revolution. How to find the value? So first, which method to use? I think about it. Okay, so this is rotated about the y. The last class tells us rotation, the axis of rotation is y. If we cut along y, can we find the radius? Everyone, see, can we find the radius? The radius, you need to find the x, right? If you find the x, you need to solve from this equation. You can imagine, if you solve this to get the x, it's complicated, right? Remember the formula? This is too complicated. Okay, so keep in mind that. So you imagine from this, the method of course, this is no hole in the middle. The method of discs, right? So remember this. And discs, this time should be does not. Works very good at least. Works well here. You know the reason, right? Because the radius, okay, and the radius is too complicated. The radius is too complicated, then the integration function is complicated. If we're going to do the calculations, it's very complicated. So means what? We will not use disk. So not cut along y. So what do we need to do? Cut along x-axis. Cut along axis, which means what? The cut a small piece of rectangle, do rotation about the y, we get the cylindrical shell, right? So the method, you know, now the method should we determine? Okay, up here. Now we determine the method should be the method of cylindrical shell, right? Cylindrical shell. I mean what? We need to cut along x. We need to integrate this time. Integrating along not y but x axis. So this time good. You determine the method. Now the formula. Remember the formula. So is this, right? As a v, the volume equals integration from a to b. Oh, what is a to b? A is 0, easy. What is b? Okay, a to b. A determines 0. What is b? B should be this, right? If project this point to here, this is b. What is b? So you need to find this in the second point and put this and this together. Of course, we know. Okay, so you can do this. If you put the y equals 6 and the y equals x squared plus x, you can solve for this point. This point after you solve to 6. Okay, it's good. And then you will have this is 2. Now we know this is 0 to 2 to integration. Okay, and then how to put the formula? Circumference is times the height times the thickness. Remember, right? It's better I do this. You cut. If I give you one cut, if I say x here to cut, see x here to cut. If we cut one means what? We cut this. This is x. If I say this is x plus delta x, and this is delta x for the increment. Okay, so we look at your cut. Should be very thin. Okay, the very thick. Okay, very thick. Can you see? Okay, so this is the cut. This is the thickness, or the width is delta x, right? So you say, so this is one piece, and take this go to rotated by the y. Okay, rotated by the y, we get a cylindrical shell. So this delta x should be what? The thickness, right? And then where is the radius or the circumference? Circumference determined by the radius. The radius is here, right? So from the radius is this long. Can you see? This is the radius. This is the radius. Or I put it like this. This is the radius, right? Radius is x. Radius is x. The one more, we need to determine how high, right? The radius can tell us what the circumference is, which is what? Circumference, which is 2 pi x, the radius x, 2 pi x. So what is 2 pi x now? You know, this should be the circumference, right? Circumference. And the times the height, where the height? The height is this, how high is the box, the rectangle. We know how high. So let me show, I put it there. Okay, this is how high. How high is this box? How high? 0 to 6. The total is 6. Do we know how high is this small? See, do we know how high this small? Or we say is this? Sorry, it's very small. This small is what x at this value. See, the function we know. Take x to here. This we know is how many? I think this you will get is x square plus x. Therefore, what is this? What is this one? Okay, this is the height. This is the height. So I put it here the height when we do the calculation should be the total 6, right? Minus this small part is x squared plus x, and you do calculation simplify 6 minus x squared minus x. Okay, this is very important. So far we have the radius, so far we have the height, have the thickness, and then from the radius we have the circumferences. Okay, plug into the formula, then we have what? The circumferences times the height. What is the height? There, 6 minus x squared minus x. Okay, you remember what that? This is the height, and then we will times the last is dx. Dx delta x thickness. This is the thickness. Okay, now the setup is done. Okay, this is very important. After we set up this, now it's just do calculation. Our going to do calculation is this. Okay, and the 2 pi we take out. Okay, take out 2 pi, and then 0 to 2. X we times that, so we have 6x minus x to the third power, right? Minus x to the second power dx. Okay, and this is a power. We easily to find the antiderivative, so it's 2 pi times antiderivative is this 3x squared minus 1/4 x raised to the fourth minus 1/3 x raised to the third, between 0 and 2. You plug in. Okay, I will skip. Okay, so you plug into calculation, we find the answer 32 pi over 3. Okay, this is the final answer. Thank you.